All right, page 752 today. First, we've got the secant segments theorem. And the secant segments theorem applies to, we got a circle, and we've got this situation. And we'll label these vertices A, B, C, D, and E. And the secant segments theorem is very wordy, so we're going to try to eliminate a lot of the words, and we're going to write some formulas. What the theorem says is that when you're finding these segment lengths, or if you're solving for a variable that represents one of these segment lengths, that this entire piece right here, AC, A to C, the entire piece times its outside piece or its exterior piece, which in this case is AB. All right, so the entire segment times the external segment is equal to the other entire piece or entire secant, which is AE, times its external piece, which is AD. So it's the whole piece times the outside piece is equal to the whole piece times the outside piece. So if you're given some values here, and we've got a 8 and an X, and then a 10 and a 6. This entire piece, AC, is equal to X plus 8 times its outside piece, which is 8, is equal to the entire second secant, which is 6 plus 10, times its exterior piece, which is 6. All right, so now we got to do the distributive property on the left side. So we get X times 8, which is 8X, plus.
Interruption. Teachers, please take a moment.
All right, so we got our X times 8 plus our 8 times 8, which is 64, equal to our 6 plus 10 is 16 times 6, which is 96. So we can subtract 64 from each side. Our 8X is equal to 96 minus 64 is 32. And then divide both sides by 8. Our X is equal to 4. Any questions there? Okay. Let's take a look at another one. Doing example 3A on the guided practice. So we've got a secant and our second secant. We've got an exterior piece equal to x and an interior piece equal to 9, an exterior piece equal to 4, and an interior piece equal to 5. All right, and the key here, we've got secants. We've got segments going through a circle, intersecting a circle at two places, and then those secants are intersecting outside of the circle. So again, it's this entire piece, the entire segment, secant, which is x plus 9, times just this outside piece, all right, which is x, equal to the entire secant, which is the 4 plus the 5, times the outside piece, which is 4. So distributive property again, we get an x squared plus 9x. And then on the right-hand side, we get 4 plus 5, which is 9, times 4, which is 36. All right, so now be careful because we've got an x squared, we've got a 9x, and we've got a 36. So we've got to get all of these terms on the same side of the equation. So we're going to subtract 36 from each side. So our x squared plus 9x minus 36 is equal to 0. Now, it's been a long time since you've factored trinomials. So I think when you get to this step, what you're going to have to do is the quadratic formula. All right? And if you remember the quadratic formula, it is, let's see, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. All right, and that's where ax squared plus bx plus c is equal to 0. So when you're doing this quadratic formula, and that's because we have a trinomial, we've got an x squared and an x in the same equation. The first thing you want to do is label your a, b, and your c. All right? Your a is whatever's in front of the x squared. Your b is whatever's in front of the x. And your c is the constant, whatever's sitting between the equal sign and the x without the x after it. So over here we got an a that's equal to 1. All right? The term in front of the x squared is a 1. Our b is equal to the 9. The b is whatever's in front of the regular x, so that's equal to 9. And our c is the constant. So our c in this case is negative 36. And then we're taking these values, we're going to substitute them into this equation, and we're going to get a couple of possible values for x. So we take x equals the opposite of the b. If the b is 9, then we've got an opposite of b, which is negative 9, plus or minus square root b squared. So we're going to go 9 squared minus 4 times a, which is 1, times c, which is negative 36, all divided by 2 times a, which is 2 times 1. So then we're going to clean up the discriminant, and the discriminant is what's under the radical. So we've got an x that's equal to negative 9 plus or minus the square root. Now, underneath this radical, we've got 9x squared, and then we got, which is 81, minus, I'm going to take 4 times 1 times 36 negative. And I get negative 144. We're going to divide all of that by 2 times 1, which is 2. Now, be real careful underneath this radical, because you're subtracting a negative, all right? You're subtracting a negative under there. It's not always going to be subtracting a negative, but it is always going to be subtraction. It's always b squared minus 4ac. But when the a or the c is negative, you're going to have a negative that you're subtracting. So be careful, because when you're subtracting a negative, it's just the same as addition. All right, so let me move this down a little bit, and we're going to finish this up. All right, so our next step is to clean up what's under this radical. So we get x equals negative 9 plus or minus 81 plus 144 equals 225, and we push square root, we get 15 all over 2. Now, what that means is it means that x is equal to negative 9 plus 15 divided by 2, and x is also equal to negative 9 minus 15 divided by 2. So the negative 9 plus 15 would be 6 divided by 2, which is 3. And this second value of x that would make this trinomial true is negative 9 minus 15, which is negative 21. I'm sorry, negative 24. So 24 negative divided by 2. Our other value of x that would make the equation true is negative 12. But what you want to keep in mind here, you've got a value of x that's 3, you've got a value of x that's negative 12. But look what we were trying to solve for. Back in the original problem, we were trying to solve for this piece right here, this segment. Well, that's not going to be a negative value, is it? All right, distance is never negative. So back down here, where we've got these two values of x, we take the negative and we just don't use it. In this case, for what we just did, it's an extraneous solution. And all we're going to use is this, x is equal to 3. All right, so be careful if you have to get into using that quadratic formula. All right, so let's take a look at one more of these. And that's example 3b there. And again, we've got the two secants intersecting outside the circle. We've got an interior piece that's 12 and an exterior piece that's 7. An interior piece that's X and an exterior piece that is 6. So again, it's the entire piece, 12 plus 7, times its corresponding outside piece, which is the 7, equal to the entire other secant, which is X plus 6, times its outside piece, which is the 6. So we get 12 plus 7, which is 19 times 7, 133, equal to distributive property again. X times 6 is 6x plus 6 times 6, which is 36. Subtract 36 from each side. So we get a 97 that's equal to 6x. And then we can divide both sides by 6. And 16.2 is equal to x. All right, so the key here, it's the entire secant times its outside piece is equal to the other entire secant times its outside piece. All right, and just be careful if you get an x squared in your equation. If you get an x squared in your equation, put everything on one side of the 0 or one side of the equation and use the quadratic formula to solve for x. All right, so your practice for today is going to start on page 753. We got problems 3 and 4. And then over on the next page, 10 through 13. And that'll be it for today.